Good morning, students. Welcome back to 9th Physical Science class. I hope you watch the video which is related to the chapter 1. Now we will discuss chapter 2, motion. I think all of you know very well, in our daily life we may observe many things are in motion. For example, moving train, moving bus, moving car, moving aeroplane, moving birds. Likewise, we may observe many objects which are in motion. See, as you know well, we are getting sunrise and sunset and seasons. Do you know how this happens? Because of the motion of earth. The motion of earth. Clear? Now here we are going to see, first one is the rest. Actually, before going to see these rest and motions, we have to learn about what is meant by relative. What is meant by relative? See, in order to see for example, if you when the sentence may get meaningful, whenever if the proper relation between the words, then only the sentence is meaningful. If there is no proper words, then that is meaningless. Likewise, if you want to express anything, the word relative is the most important for the motion. If you want to explain the motion, the word relative is plays an important role. In order to express the motion, first of all, we have to learn about the relative. Here, I am going to give a few examples to learn about the relative. For example, two persons, Ram and Shyam, are there. This is house. See, both Ram and Shyam, they are approaching to this house. So whenever if you ask Ram, he will say that the house is lies left to him. If you ask Shyam, then he will say right to him. Then tell me, among these two, who is correct here? Both are correct. Both are correct. Take one more example here. One of your friend is in Hyderabad. For him, it's a morning time, and one more friend, he is in New York. For him, night time. So according to time here, who is correct? Both are correct. Both are correct. Take one more example here. Two sticks are there. A and B. See, among these two, which one is long? B. Take one more. Then, which one is long here? A. See, according to height, here we just consider here, according to height, here relatives which is related to the height, relation which is related to the height, here which is related to the time. Is it clear? So likewise, in order to express anything or in order to express about the motion, the word relative is plays an important role for the explanation of this motion. Is it clear? The next one is here we are going to see the rest. What is rest? See, many things which we can see without changing their position with respect to time. For example, if an object does not change its position with respect to time, with the observer is called rest. Then we can say that the object is at rest. Is it clear? So it should be, there is no change in position of the object with respect to time and observer. With respect to time and observer. Then we can say that the object is at rest. Then what is meant by motion? If the position of the object is changes with respect to time and observer, then we can say that the object is in motion. See, in order to express these two terms, rest and motion, we should use the word relative. Relative, nothing but See here observer is required. So based on observer only we can say that whether the body is at rest or in motion. So in order to say that, here we have to explain one more term called reference frame. What is reference frame? Reference frame is a background for all the observations. All the observations are made from this reference frame only. See, I will give best example you. So how the bodies appears to the students, those who are sitting in classroom. The body is at rest. The body is at rest. If you see the same board from the moon, how does the body appears to you? The body is in motion. The body is in motion. See, according to observer, the motion of the object changes. Is it clear? So that is nothing but difference frame here. Fine. The next one is distance and displacement. What is distance and what is displacement? See, distance is the length of the path, the total distance covered by the total length of the path. The total length of the path is nothing but distance. Displacement is it is the shortest distance between initial and final points, at the shortest distance between any 2 points. Any 2 points. See here, now we are going to discuss in brief about distance and displacement. First of all, we will see about the distance. What is meant by distance here? The total length of the path. See, this is an path. Let the point A, B, C, D, E and F. What is distance here? The total length. For example, here A to B is 3 meters, B to C is 4 meters, C to D is 5 meters, D to E is 6 meters, E to F is 7 meters. And from A to F is 20 meters. Is it clear? So what is distance here? Distance is nothing but the total distance, that is AB plus BC plus CD plus DE plus EF. If you add all this, then AB is 3 plus BC is 4 plus 5 plus 6 plus 7. How much it is? 3 plus 4, 7, 7 plus 5, 12, 12 plus 6, 18, 18 plus 7, 25 meters. Total distance is 25 meters, but the displacement is 20 meters. 20 meters. Is it clear? That's why we told that. See, if you can observe here, the displacement is less than distance here. That's why what we say here, displacement is the shortest distance between the shortest length between two initial point is called displacement. Displacement is always less than or equals to distance. Displacement is always less than or equals to distance, or distance is always greater than or equals to displacement. Clear? So what is distance here? The total length of the path is called distance. What is displacement? The shortest distance or the shortest length between initial and final point is called displacement. Displacement is always less than or equal to distance. Distance is always greater than or equals to displacement. I will give an example to you. See, if you may start from home and you started from home and going for purchase a vegetable from the market. The distance between your home and market is 2 kilometers. See, in this case, here I am going to explain about the distance and displacement. If you may start at home and reach the market, you purchase all the vegetables and you came back. So here, the starting and final point both are same. In this case, the total distance is 2 plus 2, 4 kilometers, and the total displacement is 0 kilometers, because here both initial and final points both are coincide, both are same. If initial and final points, starting and ending point both are same, in such conditions the displacement is 0. Displacement is 0. Remember, displacement may be equals to 0, but distance is never becomes 0. Is it clear? Distance never become 0. Is it clear? So this is about a distance and a displacement. For example, one more example I will give for distance. If a person starts from point A, reaches B, the distance is 7 kilometers and moves towards north 8 kilometers. Then what is the total distance traveled by the person? 7 plus 8, 15 kilometers. Then what is displacement here? A to C, the shortest distance between initial and final point. How does we get this? So it is like a rectangle triangle. In a rectangle triangle, hypotenuse square is equals to side square plus side square. So from this 7 square plus 8 square is nothing but a displacement of the given path. Is it clear? See, remember, so distance has only magnitude, there is no direction. We can go in any directions. But displacement has magnitude and direction, both the magnitude and direction. So that we call the distance as a scalar quantity because it has only magnitude, no specified direction. Displacement is a vector quantity because it has both the magnitude and direction. Remember, next we are going to see about scalar and vector quantity. What is meant by scalar and vector quantity? A quantity which has only magnitude, no specified direction is called scalar quantity. A quantity which has both magnitude and direction is called vector quantity. So here distance is a scalar quantity because it has only direction, no specified direction. It has only magnitude, no specified direction. If you see the displacement, it has both magnitude and direction. So that the displacement is a vector quantity here. Is it clear? Same as speed and velocity, we will discuss afterwards. So here remember, distance is a scalar quantity and displacement is a vector quantity. See, generally both distance and displacement we can express in terms of meters. The basic unit of distance and displacement is meter. We can represent with small m. We can represent with small m. That is basic unit. But for longer distance we can't use this. For example, if you want to measure the distance between Vijayawada and Hyderabad, then we can say 250 kilometers or 300 kilometers, not in terms of meters. Not in terms of meters. Next, if you want to express the distance between any two houses or any two places nearby them, then we can express in terms of meters, 100 meters, 200 meters, 300 meters, like this. If you want to measure the length of the bench or length of the book, then we can measure in terms of centimeters. So according to the distance, the measuring of unit also changes. So if you want to measure the thickness of the coil, then you may use unit as millimeters. And miles also. For example, if you are traveling in sea, oceans and aeroplane, in such conditions we may use miles as unit for the distance and displacement. Is it clear? So according to the distances, the measuring of unit also changes. But anyway, the basic unit is meter for both distance and displacement. Is it clear? Fine. So here, the next one is speed and velocity. The next one is speed and velocity. So before going to see the speed and velocity, once we will see drawing displacement of vectors for displacement. Drawing vectors of displacement. How can we draw? See, look at here. A, B, C. Here the total distance is AB plus BC. This distance is AB and BC. Displacement is only AC. Only AC. A to B, let A to B is 3 meters and B to C is 4 meters. Then what about A to C? Under 3 square plus 4 square, that is Root 9 plus 16, that is equals to root 25. Root 25 means 5 meters. So 5 meters. Is it clear? So the distance is 3 plus 4, 7 meters and displacement is 5 meters. So that's why I told you displacement is always less than or equals to distance, or distance is always greater than or equals to displacement. See here, when do the magnitude of distance and displacement becomes equal? When the path must be a straight line. Whenever the path is straight line, then only we can observe the magnitude of distance and displacements are equal. Distance and displacement are equal. Here one more question I would like to ask you. When did the displacement becomes 0? So when the starting and final point both are same, in such conditions the displacement is 0. For example here, A and B. You start from A and reaches the point B. Again you start from B and reaches the point A. So here both initial and the final points are coincide, are same. Then in such conditions the displacement is 0. Displacement is 0. But whatever distance, let the distance between A and B is 3 kilometers. Then total distance is how much? 6 kilometers. 3 plus 3, 6 kilometers. Is it clear? So displacement is becomes 0, but displacement never becomes 0. Sometimes these two are equal when the path must be straight line. For example, if a body completes one complete rotation, then what is the total distance traveled by the body and displacement? The total distance is nothing but the perimeter of the circle, that is equals to 2 pi r, and total displacement is 0, because here both the starting point and final point both are coincide here. So displacement is 0, but distance is never becomes 0 here. Is it clear? So in this case the total distance traveled by the body is perimeter of the circle 2 pi r, and the total displacement is 0, because here both initial and final point both are same. Clear? The next one is speed and velocity. Generally we may use this word speed and velocity. What is speed? The simple definition of the speed is distance by time. See, I will give an example to you. Two persons A and B. They start from Hyderabad. They have to go Vijayawada. See, person A took 12 hours to reach Vijayawada. Person B took 10 hours to reach Vijayawada from the Hyderabad. See, among these two A and B, who is moving faster? Person B, because he took less time. The person who will take who did take less time to reach Vijayawada is moving faster. For example, if we conduct a running race between two students A and B, the distance is constant here. We can't change the distance. For example, the distance is 100 meters, but the time taken by the two students are different. The students who will take less time to reach the target is moving faster. The students who will take more time to reach the target is moving slower. So the distance is, if the distance is constant, if the time taken by the person is changes, then we can say that who is moving faster, who is moving slower. So simple definition of speed is nothing but what here? The distance by time. Distance by time. So what is unit of this speed? See, what is speed here? Speed we can represent with the small v. Speed, v is equals to distance by time. You can say s by t. V is equal s by t. Then v is equal distance, generally in terms of meters, time seconds. So meters per second or meter second inverse. Meter per second or meter second inverse is a unit of SI unit of speed. Is it clear? Here you have to remember one point. The speed shows only how fast the body is moving. It doesn't show any specified direction here. It doesn't show any specified direction. So that we call the speed as a scalar quantity, because it has only magnitude there is no specified direction. One more speed is there here, that is average speed. Average speed. What is average speed here? Total distance by total time taken by the body. Total time taken by the body is nothing but average speed. Units is also same as speed. Is it clear? One more speed is also there, instantaneous speed. What is instantaneous speed? The speed at an instant is called instantaneous speed. How can we measure this instantaneous speed? In order to measure instantaneous speed, we are going to use one meter called speedometer. So whenever if you are on bike, whenever if you are in journey, you can see how fast you are going by seeing the speedometer, 50 kilometers per hour, 60 kilometers per hour. If you can see at a particular instant of time, that speed what we call instantaneous speed. How can we measure this instantaneous speed? By using speedometer. Then how can we measure the distance traveled by the body? By using odometer. By using odometer we can measure the distance traveled by the body. By using speedometer we can measure the speed, the instantaneous speed of the body. Is it clear? Fine. Next we have uniform speed also. What is meant by uniform? Equal distances. If a body can cover equal distances in equal intervals of time, then we can say that the body is moving with uniform speed. For example, if the road is highway, you are going on highway road, then you can maintain the constant speed. For example, 5 to 10 minutes, 60 kilometers per hour. And next 5 to 10 minutes, 60 kilometers per hour. Next 5 to 10 minutes, 60 kilometers per hour. So in all the cases you are maintaining the constant speed. That is, you're covering equal distance in equal intervals of time. Then we can say that the body is moving with uniform speed. If the body is moves with uniform speed in such condition, both average speed and instantaneous speeds are equal. When the body is moving with uniform speed, then its instantaneous speed and average speeds also equal. For example, first 1 hour 50 kilometers per hour, second 1 hour 50 kilometers per hour, third hour 50 kilometers per hour. Then what is instantaneous speed here? 50 kilometers per hour. What is average speed here? 50 plus 50 by 3. 150 by 3. Again you are getting 50 kilometers per hour. Is it clear? So whenever if your body is moving with uniform speed at all the time, then we can say that it's instantaneous speed. At the same time, uniform speed is also constant only, is same only. Is it clear? So just now I told you the speed is a scalar quantity because it has only magnitude. So we can say how fast the body is moving, but here we cannot decide in which direction it is moving. So in order to express that in which direction it is moving, we are going to introduce one more physical quantity called velocity. Here velocity represents both magnitude and direction. I will give the best example to you here, okay? For example, 50 kilometers per hour. 50 kilometers per hour due east. Here 50 kilometers per hour is represents only the how fast the body is moving, nothing but speed. It won't be decide about the direction of the body. But if you see the second one, 50 kilometers per hour due east means the body is moving towards east with a speed of 50 kilometers per hour. So in order to express the direction of the body, here we introduce the word called velocity. So velocity can represents both magnitude and direction. So that we call velocity is a vector quantity. What is velocity here? Displacement by time is nothing but velocity. Then what about average velocity? Total displacement by total time. Then what is uniform velocity? If a body covers equal displacements in equal intervals of time, then we can say the body moving with uniform velocity. Remember, when the path must be straight line, then only we can observe uniform velocity. Rest of the cases, when the body moving curved path or circular path, in such conditions, the body does not maintain the constant velocity. So remaining parts we will discuss in the next video. If you want to learn more about this lesson, you please watch this video again and again. Thank you for learning.